Hello, and welcome to the fourth of a series of 5 webinars designed to provide information about the analytics process and the content areas for the CAP exam. In this webinar, we will discuss Domain 4 methodology. The final webinar in the series discussing Domains 5 through 7 will be presented on February 4th, and I hope that you will attend that as well. A little housekeeping. The presentation will continue for about 45 minutes. We'll hold time at the end for questions. And if at any time during the presentation you think of a question you want answered, just send it in. If we don't answer it during the presentation, we can follow up later and provide an answer. But you will have to provide to us your contact information so we can follow up. Incidentally, there will be polls during the presentation so that you can provide us with some information about what you think of some of the questions. Our presenter today is Dr. Subhashish Samaddar, a member of the faculty of the Department of Managerial Sciences at Georgia State University in Atlanta. Sub is the coordinator of the PhD program in Decision Sciences. Before joining Georgia State, he was the State Farm Associate Professor of Decision Sciences at Western Illinois. Sub's research focuses on managing operations, information technology, and knowledge systems for enhancing organizational effectiveness. He is an international expert in this field. His teaching and research has been funded by grants from State Farm Insurance Company, from Microsoft, from Texas Instruments, from the Center for Disease Control, from Western Illinois University, and Georgia State. Sub has been widely published and is a member of the Decision Sciences Institute and Informs, where he currently serves as the editorial review board of the Journal of Operations Management, Decision Sciences, Journal of Strategic Information Systems, and is a feature editor of Decision Information, Decision Line. He is the member and past chair of the Information Technology Strategy Committee of the Decision Sciences Institute, and that is a mouthful. Sub has consulted with a number of companies: Fortis Insurance Group, Ford Motor Company, State Farm Insurance, Delta Airlines, and more. He served as the Chief Knowledge Officer of VoiceCore, and in addition, he was the co-chair of the committee that wrote the CAP study guide. Sub is himself a CAP. And now here is Sub Samaddar presenting to you Domain 4 methodology. Go ahead, Sub. Take it away.
Thank you, Louis. Welcome to all of you. And as she said, we'll be talking today about Certified Analytics Professional Exam preparation, especially on the topic of Domain 4 methodology selection. Just one quick word before I go on. The Informs conducted a study of all the practitioners and did an excellent job on a job task analysis, which created, as we'll show you very soon, domains of knowledge and task requirements for a successful and effective analytics professional. And currently, I direct an MS in Analytics program at Georgia State University, which was, when we were creating it, we did look at the job task analysis results of Informs, so it has influenced our thinking process, and it's a great job that was done by Informs. Having said that, let me move on to our next slide. Today's agenda mostly will be, we'll follow this. We'll talk about the job task analysis I just mentioned very briefly, because you can also hear about this in the other presentations of the same series. And then mostly we'll focus on how to prepare for this topic, what to know and things like that, how to prepare yourself. It doesn't matter how long we have been working in this field. we tend to get very deep and go deep into maybe one or two methods. And I know people and friends and colleagues that label themselves, I'm a simulation guy in IBM, or I'm a data mining person. So remember, this test is about multiple methods and being able to choose the correct one. So it will be good to refresh your capabilities and expertise in these methods, and we'll talk about that as it's coming up. And as she said, we'll take questions. You can send the question in live, as well as we'll have some example questions to talk about at the end of it. So don't be bashful. Go ahead and send your questions as you listen to this presentation. Next. Well, this is the view of the job task analysis done by Informs, and that has informed a lot of creative tasks, as I was mentioning earlier about creating even a master's program, etc. Now, talking about those domains, there are 7 domains you can look at. There have been already presentations on the first 3, business problem framing, analytics problem framing, and data. To give you an idea that what we'll talk about today is on domain number 4, which is methodology selection. However, what has been already decided upon in domain 1, domain 2, and domain 3 could and would influence the choice making in section 4. So let me give a quick example. I had a client where they came to me in terms of business framing issue. They told me that they have a sales problem. They had a forecasting problem, and so when we really looked into it, ultimately we found out that it was actually an inventory management problem they had, not necessarily a forecasting problem. So that is the essence example of when you talk to a client, you're working on a project. Your client might have different ideas and so forth, but then you have to investigate those ideas to really frame the business problem correctly, and then after you choose that, if you then decided, well, it's really an inventory management problem, then what are the techniques and models? Well, first, can we really frame this as an analytic problem? And it may be that it is not really an analytical problem. It is that it may be a political problem, maybe a relationship with the vendor management issues. So it may not be an analytical problem. But if you do ultimately agree or come to conclusion with your client that, well, yeah, we need to have a inventory management modeling, then you're looking into, well, do we have data? That's the domain number 3. Can we apply this model? And after that passes data consideration, data cleaning, data availability, the accuracy of data, then you move on to decide, well, what kind of inventory model I'm going to use, and so forth. Anyway, that's just a real example I gave you quickly. And so today we're going to talk about that methodology selection. And after we are done today, there will be oncoming, as she said earlier, presentation on model building and other sections, which will also influenced by the choice you make in domain number 4. So domain number 4, along with other domains, play a very important role in the task as an analyst or analytics we do. Before I move on with my section, I just wanted to give you a taste of what kind of sort of testing are there in this. So this is just a sample question. Let me read out to you. You can look at it with me. And we'll talk about its answer later at the later part of the presentation. But this is the sort of things that we will be talking about in the selection. That is the task one has to do while taking the test. A clothing company wants to use analytics to decide which customers to send a promotional catalog in order to attain a targeted response rate. Which of the following techniques would be the most appropriate to use for making this decision? And it gives you 4 choices: integer programming, logistic regression, analysis of variance, and linear regression. Now, we'll talk about this later. I want you to just think about, this is the area we're getting into. It is not just about knowing one method well. It is about knowing and being able to compare and contrast and make a choice, an appropriate choice of the method. And we'll talk about how that choice can be done and how you can prepare for it, especially when taking a test like CAP. These type of questions will roughly, from structural point of view, from the test, of the test, these are the percentage proportion of these domains contribution or role in the test. And as you can see, methodology selection plays roughly 15% or 12 to 18% range of the test. So it is a good amount of chunk of questioning that will come from here. And also, as I said, some of the knowledge of methodology selection also influence what happens in the model building. Also, in an iterative manner, goes back to problem framing choices also. For example, if you come to methodology section, you have done the first three in your work, and suddenly you find that, well, there is the appropriate method is not possible unless you change or get new data or change the problem framing, then that's an iterative situation. You go back there. Rest of my talk is in the context of that thinking that it is an iterative process, and you're trying to make a most appropriate selection. And we'll talk about that appropriateness coming up and how to get there. So in the selection task, mostly you're looking at your job is to identify available problem-solving approaches. So here comes. It is a good challenge to take, especially when we are practicing and doing something all our life and one or two types of methods, that you have to really have a broad idea of what methods are out there that you don't use even. But now when taking the test, you need to know what they are good for, how they compare and contrast with each of them. I'll talk more about that. That is where the identification comes. That means how do you select out of all these? So you need to know what methods are out there. That's the first part. And then you need to sort of freshen up how do I choose them. And that's where the detailed knowledge of those methods become handy. And some of these will come from your last years of work experience and so forth. Some of these also come from knowing the method itself. And of course, let me also admit, even the best of us, we do not know all of everything. So there you have to have your way of organizing this information in your head. And then corresponding comes selecting software tools that goes hand in hand with the method that you select to solve a problem. Item number 3 and 4, test approaches and selection approaches. These are not part of this talk. These are actually ultimately when you have implemented the model, how do you test the model for its efficacy and effectiveness. And these two are not part of they have an asterisk on them. These are not part of the CAP test. So let's now delve more into this methodology selection task. Okay, so in this task, the two important knowledge components, the K in that represents knowledge, is modeling options. That's what I was talking about earlier, and this we are putting together. When we said modeling options, then you need to know what is out there. What are the possible choices you have? And then you also need to know some about the data architecture, meaning data organization. Will data be available? And it's one of the areas that I find with my colleagues and clients that a lot of companies are willing to buy new software, or they can get to a software and methods and so forth, but data is missing, or data is completely inaccurate, well, not completely, to an extent inaccurate, unreliable, unavailable. So these are serious consideration before we can finalize on selection of a method, as you probably know already. All right, so what are we talking about when we're saying, well, what is out there? So to organize that thinking and knowledge, CAP, as well as based on our practices, you can classify at least 3 groups of models and methods. First, starting with prescriptive model. These models actually answer the question that what is the best outcome. As you will see, it also requires very reliable and accurate, highly accurate data. And in optimization, for example, these are the methods under prescriptive model. Linear programming, integer programming, nonlinear programming, and there's a whole bunch of a list of these kind of techniques, such as mixed integer, network optimization, dynamic programming. By the way, you can get a full list of these techniques in the handbook that we created for CAP test, and this is, I think, downloadable from Inform's website, and it will be good practice to look at that. And most of my talks include some portions of this book. So if you need to dig more, you can go to this chapter of method selection. I think it's chapter number 5. Yeah, and it's domain number 4. So you can brush up there also some of these techniques. And there could be a stochastic optimization method where the randomness of the system comes into play. Your constants could be random, your variables could be random, etc. Okay, so that's, however, these models optimize with relying on high accurate data and correct formulation. It can prescribe what should be done, so to speak, to get the best outcome. And it could tell you how to allocate your resources to get the best profit and so forth. The second class of methods are known as predictive methods. This type of models answer questions like what could happen. These mostly use statistics and probabilities, and the data don't have to be, well, of course you can use accurate data if you have it, but the data need is not that highly accurate, but it also allows for chances or probabilities. So there is no one guaranteed result. However, it gives you a good idea of what could happen. And example techniques are simulation. There could be different types of simulations such as Monte Carlo, as well as event-based simulation, and then regression techniques, which tries to correlate X variables with a dependent Y variable, mostly used for forecast, as well as causal explanation of a behavior. Statistical inferences, you can look at probability and create intervals and so forth to make a conclusion about a population. Classification, clustering. Artificial intelligence has been out there for a while, like neural networks. They try to also find a relationship between input X variables with dependent variables. Game theory, these are all strategic choice-making type methods. Once again, this is not an exhaustive list, and my talk would not be teaching you these topics, but you need to start refreshing on these. You probably have taken courses as well as you have been working in some of these yourself, but before you take the test, it will be a good idea to refresh all these methods and then get ready for the test. The third and the last class of methods are known as descriptive models, and these are the ones that tell you what happened. Meaning, it's look at the past data and try to organize them into charts and graphs to show you a dominant, behavior, high frequency behavior, and maybe leading to an outlier behavior, and so forth. It sort of uses the past data to get insight to the problem, and generally it leads to a second round of analysis or analytics and adoption of methods and refining the definition of the problem. Numerical presentations, like instead of using charts and graphs, you can use mean, median, mode, distribution of data to get the skewness of the data. For example, if you look at the earning of people and over age, and you can get a skew on the earning on the age at a certain point of time. In our life, we make more money than other times of our life. So these data is generally most likely non-normal distribution. So now we're talking about presenting your data not only by graphs, but also making sense of the data by looking at some of the numerical measures. And these tell you again what we know about, or what we should know about the problem that your client is experiencing. That means what has happened. This is a summary slide. It is in our study guide also. You can look back. It puts together now to give you an idea of comparing and contrasting them. Here are the three groups. On the left-hand side, we have already discussed that, descriptive analytics to predictive analytics to prescriptive analytics. On the right-hand side is something new that I want to make sure we discuss. Data needs and benefits. Data needs, well, what kind of data do I need? Well, it is telling us, and we would like to agree with this picture overall, which is the predictive analytics will need very high quality data. It will need accurate data. It cannot have chances in it, so to speak, what ifs and so forth. On the other hand, it gives you a lot of benefits in the sense that you can recommend or prescribe a set of actions to your clients to achieve their goals in a very pinpointed manner. So basically, it is high value, high impact model with higher need for data accuracy, etc. If you go to the other end of this, the bottom end of it, we are showing medium level of benefits and medium level of data needs. Again, that sort of kind of support descriptive analytics end of this continuum. So when you are comparing and contrasting different types of models, we need to think about where they belong in these groups, and that will also tell us what kind of need they have and what kind of impact they have. And then this is the science part of it, and then comes the art part of it, which is then you decide, depending on client's need, what is the best situation you can get into or you can adopt for your client. And we're going to talk a little bit about this coming up, this compare and contrast. So I would say, in the beginning of your, well, with all your knowledge and experience and refresher course and all that, you might start here. You first do two types of compare and contrast analysis. First one is you look at this between approach. That means, is it when I say between approach, what we're saying is you like to make a decision, at least you come to an approximate decision where is this problem more suitable for prescriptive, or is it predictive, or is it a descriptive analysis? So that's what is sort of will give you which of these way you will go, or the boxes you will go in. So that has to be decided for us. And to give an example, helps with the determining whether you need a regression model and optimization model. Well, I have some questions coming up. If time permitting, we'll share those. By the way, all the questions here, example questions, are also in the study guide. If we don't have time today, you can go back and look at them. But anyway, let's say, so basically you are thinking, is it really a regression model means they're in your predictive model? Is it more of a forecasting or causal understanding of the problem? Or is it an optimization problem when I tell my client, hey, you allocate resources here, you allocate resources there, and then your profit will be maximized? There is no chance or probability or distributions are involved. Or sometimes you will also find, I had some projects with clients where they had to do a combination of it. So they first used a forecasting method to forecast certain demand, and then they went back and ran an optimization model to make sure that that demand is met while, that's a constraint of the model, and while, let's say, maximizing a profit function. So a combination is also possible. So you have to keep your mind open in terms of read the question carefully to see whether that's where the questionnaire is leading you to. But your initial analysis, your thinking starts here. That is it a problem? Is it a prescriptive model, descriptive model, or a predictive model first? Then you take the type 2 compare contrast. So within one of these chosen boxes or methods, what do I need? So if we already have decided a predictive approach, that will be the best. So do I need a time series or a regression? Comes the question. Now you need to have the understanding, working as well as nuanced understanding of regression and time series. Time series, let's say I have a client that have no historical data, they're a new company. Maybe time series may not be possible because they don't have historical data. Or maybe they're introducing a new product. There is no other examples as such out there. Maybe I cannot do a time series, but I can do a regression, which is a causal model, cross-sectional model, where I'm going to look at, why people buy a new product or a new toothpaste, for example. So that's where now you're analyzing within those three classes, and you're thinking, hey, within this class, what's the best approach would be for my client? Again, there could be prescriptive approaches, again, linear programming versus mixed integer linear programming. So then again, you need the knowledge of what this method can do for you, as well as what will be more applicable. And I think I have an example question coming up on this later. Descriptive approach. Once again, within the descriptive approach, which one is the best for here? Let's say histogram versus a table, the tabular approach, 2 by 2, m by n frequency table. So which one should I use? Well, histogram, maybe it's one dimension, one x variable, and I'm looking at frequencies of different classification. Let's say I'm looking at gender. So I am looking at a frequency of male and frequency of female, and I'm done. However, if I'm looking at a gender effect on happiness and the other variable is income, so I need a high income, low income, as well as male, female, and I do a 2 by 2 frequency table, then I put the observations in there, and then I can comment whether these two affect their happiness and what kind of effect they might have. So once again, it all depends on what the problem goals are and what kind of approaches might be handy. So far, these are mostly scientific talk, meaning these methods are certain ways they do things and they don't do things. For example, so we have already discussed that to an extent. I'm going to remind it a little later. But now, sort of non-scientific side of it, that's the art side of it, when you're making a selection, these are some of the criteria that selection of methodology criteria dependent on time available. Okay, I know what's the best method. However, maybe my client doesn't have that much time left to do, so I might compromise. And again, a question in the exam will be sensitive to that, and then maybe the questioner is really leading to that type of an answer than a very written or very pure answer for a method selection. Accuracy needed. Maybe my client is saying, well, I don't need a very, very high fidelity, high accuracy model. As long as there's some approximation, I can live with it. So again, it's sort of an art, quote-unquote, art side of the problem. Relevance of methodology, scope of project. Yes, again, yes, I know that a simulation, for example, it's a very interesting example I share with people that yeah, there's some noise outside of my door. Okay, we'll try to get rid of it. All right, sorry about that. So if somebody does simulation all their life, and I'm not trying to just look down on the simulation or anything. I do simulation myself, but it might look like, well, I can do simulation for almost everything of any problem I have. But of course, we know that's not the very right thing to do. So relevance and the scope of the project should be a consideration that, well, can I do simulation or not, or should I be doing it? Accuracy of data, we talked about that before. Data availability and readiness. Once again, that's the organizational condition that needs to be there, or that needs to be considered before you select a method. You cannot select a high data need method for a client that don't have available data, etc. So, and resource available, how much they can put in, the staff consideration, and so forth. And there's the popularity of methods. Some of us, and best of us also have this biases. We sometimes are very, biased to some particular methods, or sometimes there is a lot of, noise out there in the market that a particular technique is very popular, and there may be a slight to accept that model or method, but that may not be the best choice for the client. So once again, client considerations should be used. Client and all these other concerns that are on the screen, they should be all used together as sort of a beyond the science approach to the method selection. Very quickly, all our life we work on a methods and so forth, and we tend to know very well what a method can do for us. But it will be also good to refresh on what a method cannot do for us. Again, we all have this in ourselves mostly, and so my one suggestion will be stay unbiased as you walk into as you prepare for this test. Don't fall in love with one or two methods that you know very well, because that may not be the correct answer to your question, though it might look like to you. So do some deeper analysis as some of the steps I mentioned. Do a compare contrast and also look at the appropriateness of these methods for the particular question or your client. Well, we are at the half mark, and select software tools. In general, the same principle that we talked about earlier is applicable here. In general, the client needs, the data needs, the accuracy, and so forth, and what the methods want to do. If I'm going to do a forecasting versus optimization, I might have a different software requirement. And also, a disclaimer, CAP and Informs are software neutral by intent, and so I won't be mentioning any software, and we're not going to discuss any particular name or so forth. But in general, there has to be an alignment of the methods you choose and an available software, its capacity, the data availability. All these go into thinking of or choosing or making a selection. And here are some example software categories that we can mention again for preparing for this test. You might like to spend some time, and all of you that are listening to this talk today, you have some work done in at least one or two or three of them for sure. And if you have not, and most likely you have not done in all of them, so go ahead and talk to your colleagues. And a good organization in analytics department, they will have people with different skill sets and methods. So talk to your colleagues, form a team, work together, and get to know. I mean, pick up some books, maybe some courses here and there to really get to know about these systems and available software. But again, CAP doesn't ask a specific named out software, but there are questions that can be influenced by the knowledge of this type of system, spreadsheets with statistical optimization, simulation, etc. So, and also operating system. Now we also have structured data and unstructured data, social media data. So their handling are different than non-traditional databases. So a good refresher in that also will be helpful. Now, I need to remind you, including myself, none of us are really can have all the knowledge of all the methods and all the software. So that's not the goal here. Just to get the dominant ones, at least do as much you can to know what they do and what they cannot do, what they can handle and they cannot handle. This is test approaches. That means after you've done the modeling, it is being implemented, and how to test its efficacy. This is not part of the test. But in general, you look at verification and validation and how you use data to build and validate model. The classic 80-20 rule. You use 80% of your data, and then you apply to 20% of remaining data. But to see how they're doing the work or predicting or forecasting, whatever the purpose of the model. But this is not the part of this talk, but that's part of task and analyst does. While
excuse me, Sub, I can break in for a minute. We have a question. What are K17 software tools? I just wanted to clarify that the K17 designation simply means this is Knowledge Statement 17, and the content of the knowledge statement is software tools. So there is no special K17 software tool. It is simply the knowledge statement that includes software tools. Thanks, Doug.
Yes.
Go ahead.
And also in our Chapter 5, there is a list of software and type, the classification of software and examples are there without taking any particular name of a software. So the questioner can look at the Chapter 5 of the study guide. Thank you. Okay, moving on. The task 4 also not part of the exam, so I'm going to move on from here. Basically, this slide tells you what you need to know. Once again, this is not part of the main test, but in a real project, an analyst has to do this. Is it accurate method, or again going all the way to it's a scientific, but did you select based on other non-scientific ideas and thoughts and data accuracy? We already talked about all this, but this sort of becomes part of the play as you select your method and start up implementing the project. Okay, moving on. Oh, test hints. Well, this has been there before in the previous talks. Very quickly, you need to, read each question carefully. And we all of us have our own test taking approaches. So, just sharpen it up and try to looking at the structure that we showed you in the beginning. Let me, in a very early stage, we showed you how many percentage of questions come from which topic or which domain knowledge. Focus on that when you're reading a question. Try to link it through that, and it might give you a better access to your knowledge and so forth. Try to reason why some answer is actually wrong, and change answer if you think there is a valid reason, of course. And time management, as usual, is always very important. Now, let's try to discuss some sample question, and then I'll try to finish with some parting points or takeaway points at the end. Let's see. I'll do some water. This is the question I showed you in the beginning. And take a moment and think about the answer. Once again, let's read the question. A clothing company wants to use analytics to decide which customers to send a promotional catalog in order to attain a targeted response rate. Which of the following techniques would be the most appropriate to use for making this decision? Integer programming, logistic regression, analysis of variance, and linear regression. I'll give you already saw this before. I'll give you a few seconds to think about this and make a choice. And see what would be your answer. And let's say in 2 or 3 seconds, we'll go to the next and discuss the answer. And I don't think we have voting capability on this question. Louis and Liz, you can correct me if that is not true. Okay, let's try to understand the answer to this question and how that choice was made. Okay. Integer programming is an optimization technique. And what they're trying to do, the problem statement is regarding prediction. That means they're trying to predict which customer group will buy or adopt whatever, and which will not. It is more like a 0-1 type of prediction. So it's a prediction, so optimization model will not work. Optimization model doesn't predict. It tells you what to do and then what should you get, what the best outcome be. Logistic regression is a correct one. Before I discuss that, let's also look at C, analysis of variance. Incorrect. Why? These are a collection of statistical methods used to analyze the differences between groups, within groups, etc. Again, it is not a prediction model. You can look at the behavior and the variance in the behavior of any system or anything of your interest, but it doesn't give you a prediction. Linear regression would come close. Okay, let's see why it was incorrect. Linear regression, the y or dependent variable is a continuous variable. This is a model used to use relationship between continuous dependent variable and one or more independent variables. That's the causal variable. However, the client needs to target buyer or non-buyer. So it's a 0-1 type group. That is not a continuous variable. And that's why linear regression, although come very close to a correct answer, but it is not a correct answer. And again, this is an example where you are looking, first of all, if you recall, I said, first, do a compare and contrast between types of methods or classification of methods. Integer programming is an optimization method, and it's a prescriptive tool. So first we decide it's not a prescriptive tool we are looking for. So A will be out even that way. Now B and D, these are analysis of variance. These are sort of in the predictive box, but then you're fine-tuning within that box which one should be the correct one, and in this case, logistic regression. So this is an example of where you have used both type 1 and type 2 that I mentioned earlier in terms of compare and contrast. Let's take this sample question number 2. Should I look at the questions on these? 1 second. Okay, there are some questions, but not in the example. So, okay, I'll take those questions after I'm done with this 4 example, and then I'll go to further example. Let's go back to. All right. Sample question number 2: which of the following is an effective optimization method? Analysis of variance, generalized linear regression, Box-Jenkins method, mixed integer programming. Take 2 or 3 seconds. Take a look. And I'll pause for 3-4 seconds. Then we'll discuss the answer. Okay. Did you make your choice? Keep your choice, and again, we're not able to take votes on these, so just keep your choice and see, listen, and let's go along with our discussion. So, by the way, the stem of the question tells you it's an optimization that you need. So it comes down to what methods of these will do optimization. Mixed integer program, or MILP, mixed integer program. It strikes out to me directly. However, that's the correct choice. It does an optimization. But why the others are not? Again, ANOVA, of course, as we discussed before, analysis of variance, it doesn't do an optimization. It could use to create a solution, but it is not an optimization method. How about GLM? And now that is a method where again they use minimization of error and so forth. But again, it is a prediction model. It is not an optimization model not in and of itself. Same goes with Box-Jenkins method also. So the correct answer is mixed integer programming. Sample question 3. A furniture maker would like to determine the most profitable mix of items to produce. There are well-known budgetary constraints. Each piece of furniture is made of a predetermined amount of material with known cost, and demand is known. Which of the following analytical techniques is the most appropriate one to solve this problem? Well, I'll give you 3 or 4 seconds to think about it, and we'll then discuss the answer. First answer: optimization problem, multiple regression problem, data mining problem, and forecasting problem. Forecasting method, I'm sorry. So ABC. Okay, let's discuss the answer. Let me discuss some nuances here a little bit. The people that are trained in optimization, they could pick this one up very fast. But even if you're not, well, you first need to know, well, again, you need the broader knowledge of all these methods, and you realize that, well, all these integer programming, linear programming, they do optimization, and A is the only choice in that way, so that becomes the correct answer. The problem statement describes an optimization problem. Multiple regression is not, because it's a causal forecasting model. If you think about the forecasting itself, so B and D are easy choice to be out. Data mining, this is used to understand patterns in data. So once again, it is not asking, data mining is not a method that helps you optimize much or anything. It will not help furniture maker decide the mix of the furniture they have to make. By the way, it's a classical product mix problem from operation research or linear programming type training. But even if you don't have that training, you can come back to this question with the correct answer by thinking about what kind of problem it is. It is an optimization problem, and does multiple regression optimize anything? And what's the purpose of it? As you can see, you do need to know about all these methods as well, what they can do versus they cannot do, and that could help you out in making a correct selection. Okay, long description. Let's read this. A company ships products from a single dock at their warehouse. The time to load shipments depends on the experience of the crew, products being shipped, and weather. The company thinks there is significant unmet demand for their products and would like to build another dock in order to meet this demand. They ask you to build a model and determine if the revenue from the additional products sold will cover the cost of the second dock within 2 years of it becoming operational. Which of the following is the most appropriate modeling approach? So they ask you to build a model and determine if the revenue from the additional products sold will cover the cost of second dock within 2 years of it becoming operational. Choice A, optimization because there's transportation problem. Choice B, optimization because the company's objective is to maximize profit and because capacity at the dock is a limited resource. Just to explain the interesting choices here, they're both optimization, but you realize A and B is actually justifying the answer differently. So this is a little deeper end to the knowledge of the method itself. And C, forecasting because you can determine the throughput at the dock, calculate the net revenue, and do a one-time shot basically, and compare this with the cost of the new dock. D, discrete event simulation because there are a sequence of discrete random events through time. What are discrete random events? Well, you need to understand those. That means the dock is there and the demands are coming, the products or the boxes, etc. So, well, take 3 or 4 seconds, think about it, time to zero in on a choice, and see where we go from here. Okay. I think I clicked it too fast, but anyway. First, A is incorrect because you might think it's a classical transportation problem, but it is not. The question is to determine if the revenue from the additional products sold cover the cost of the second dock within 2 years of it becoming operational. This is not a transportation problem, really. Transportation problem involves scheduling of movements involved and with the constant situation of trucks and flows of material. So though it has the words from transportation problem, it is not a transportation optimization problem. B is wrong because they want to maximize profit. However, the question is to determine if the revenue from the additional products sold will cover the cost of the second dock. They didn't explicitly say they want to really maximize profit, which is a good assumption to make, I think. So this question is about the payout period for the investment of building a second dock. It is not about how the company can maximize profit. Once again, this connects with your client's need. What client wants to do is to see whether they can pay this off in 2 years. They are not really asking for optimization of any kind. Forecasting is useful here, but why it is wrong here in terms of the problem statement says the time to load shipments depends on the experience of the crew, products being shipped, and the weather. The throughput of the dock, that means there is a variance in these people's abilities and so forth. So once you get into this variance or uncertainty, all the optimization methods are generally irrelevant. Again, another argument against optimization here. But it is difficult. Due to this range and sequence of events, it is difficult to get an accurate estimate of the throughput at the dock deterministically. That really means that you have data that doesn't have any variation to it, and then you use it to calculate the net revenue. So you cannot really do it in one shot. That means you look at one set of numbers of their performance capability and speed, etc., and you calculate one profit. What it needs to look at different variations of loads coming, and people are working with the lower end of their ability, higher end of their ability. So once you get into this kind of situation, you really have a variance in your system or uncertainty in the system. So it is most likely it will go for a simulation. And the only simulation choice you have is discrete event, which is in this case is more likely to be used. But you can still answer this question D as a correct answer because The time to load shipments depends on the experience of the crew, etc. So that was the catch. That means there's a variance in each of these capabilities and their performance. And given there is a sequence of random events, now you go for discrete event simulation. But you can see that you can find out that A, B, C are wrong without even have to think about discrete event. As long as you come to simulation, you got the correct answer to this question. All right, let me now, I have some more questions in the voting box, but it is 4:51. I'm going to look at the questions to answer. Okay, what's the way to do it? Just read and answer? Okay.
Yes, please.
What are some... Well, first question, what are some dominant kinds of software from Sub's point of view? Well, once again, I cannot take any, kinds of software. Well, at this point, again, depending on what skill set you're going after, if you're going to go for forecasting and you are going to answer questions about a method that requires a forecasting, then you're looking at the forecasting dominance in this. So there you won't be seeking a software which is sort of a me-too product that also does optimization and so forth. So again, it is determined by what is the problem at hand for you. And if it is a forecasting versus optimization, could be a simulation, etc. Do remember, a lot of software today, I see a lot of integration and convergence. There's a whole suite of software that's coming out. I won't take any names. These are all big names, and they will do X as well as they do Y. They will do Z, all sorts of things. So, in terms of dominance, it depends on the problem your client has, and that decides where you go. So, a good knowledge to have, a meta knowledge to have, is what software does what best in terms of their metric size inside, the capability that they can handle. For example, optimization software, how many numbers of variables they can handle, how many constants, etc., and what kind of algorithm they use to come to a quicker solution to the problem, and so forth. I'll go ahead and take the next one. Hope that helps. And by the way, you can follow up on this if you want. If you can email your questions. If you're software vendor neutral, you probably should be saying big data instead of specifically mentioning Hadoop. Yes, we thought Hadoop is still a regular big play, but you may be correct on this. Okay. How deep does your knowledge of various predictive prescriptive techniques need to be for the exam? Well, the easy answer is, very deep, but more importantly, get to know at least some of all of them, meaning what they can or cannot do. You might use some of the problems, etc., and try to apply and talk to other people. Are there any specific resources where one can get a fair idea and usage about various data analysis methods? At this point, you can buy Thesaurus type book where there is mention of all methods in a global way. And in our study guide, we try to do a little bit of this. At the end, we give an index. But there is very varied source, and the new books are coming out nowadays on this. So you have to just look around. If the presenter ran out of time, then how can someone prepare the exam seek out those portions of the presentation? Well, we didn't really run out of time, but if you have further questions, of course, you can contact Louise Worley. Her information will be there at the end of the slide. Okay.
You can send a message, you can send a message to certification@informs.org. That way you don't even have to remember how to spell my name.
Okay, that's good. Hope you guys getting that. So do that, write to that address. Okay. Are there any specific so we can get a fair idea of usage about various data analysis methods? Once again, it's the same similar question. There is no one specific resource, but right now it is pretty much varied. But there are some authors writing books that are geared to integration of this knowledge. So once again, no suggestions right now. Suppose you have know about technique, do not know one. Okay, it's an interesting question. Suppose you have used and know about 2 techniques and do not know one. How do you go around this problem? It is difficult to go around this problem, so it's good to know. But still, taking the question as it is, try to read the question and try to see whether there's some that art part of the presentation is or the method is there, not only just the science, and that can give you an idea of how to eliminate the wrong answers. Maybe we can chat about this more later if you contact later. Next, hello Sub, how do you make an appropriate choice if you do not know one of the choice or techniques? Again, similar questions. First of all, it will be great if you do know that. There is no shortcut to this. But the only thing left for you is to eliminate wrong answers by knowing what you know. And so you can reject those and try to minimize the choices that you have. Once again, I'd love to discuss this much. We'll continue this later. All right. 4:56. Let me quickly close this. I think we addressed all the questions. I wanted to go to some of the takeaway points. Try to understand the classification. We talked about prescriptive, predictive, and descriptive. Put your tools in those boxes and try to compare and contrast them. And again, it's a very good way to have meta-knowledge about different methods. Once again, as some of you asked, that if I don't know something, how do I know? Well, you won't know unless you really get into that. At least by comparing and contrasting them by groups, you know what is possible in a group. So if you know 3 tools in a group and you don't know the 4th one, you can still sort of reasonably well guess what it cannot or cannot do. It's like their own family members, so to speak. So they come in the same group. So that's one way to think about it. A problem may be solved using more than one methodology. Avoid your own biases. This is the thing about the hammer and nail metaphor. You know, if you have only one hammer, then only hammer as your tool, then all problems looks like nails. So be careful and don't fall in love with your hammer. At the same time, there is another version, the reverse version of this problem is if you have multiple different types of problem. You have more. You know a lot of methodologies, and you might try to use this, all these methodologies for one problem, and try to get impress your client by showing 5 different techniques. But remember, 5 different techniques will most likely not be needed for a particular case or situation, and that's where it comes on the idea of the art versus science. You can also try to model at the aggregation level where it makes more sense, and accuracy of the problem is very important. Point number 5 is also very important. I'm going to finish with the methodologies used to solve problems are scientific. However, selecting the appropriate one is a combination of art and science. The soft information about your client and client's problem is very important to consider in your way of finding out the best method. Well, I guess we are almost tracking the clock. Bonus tip for taking the CAP exam. You probably know this. All of you are professionals. You've taken tests all your life. Just breathe well, relax, and I'm going to add one thing. Keep your biases for a method outside of the door of the exam hall. Have an open mind and look at the nuances of the question descriptions. And so if you are a simulation lover or optimization lover, or forecasting, or some method lover, keep that love little in check, and so look at all other possibilities. Take a deep breath and dive in. Okay, I think the last slide is coming up. This is the contact information, and that's what she was announcing earlier. Verification@informs.org. Please feel free to send your questions to that address, and this is her information. Now I was able to get to this page, so you have it. How's that?
That's lovely. Thank you very much, Sub. You ended almost exactly on time. And thank you all for listening.
Well, that's the experience of 25 years of teaching a classroom.
Experience counts, Sub.
Yeah, students
Anyhow,
don't like
I
to.
hope the rest of you will join in on our webinar, the last one in the series, on the 4th of February. And again, if you have questions, send them to the contact information on the screen in front of you. And thanks again, Sub. That was really wonderful.
Thank you. I enjoyed it and hope the listeners